Hello everyone, welcome to IMS Gate Academy. So we are starting our foundation course on theory of machine subject, right? So already we have started our kinematic analysis part, in which we have discussed about kinematic link, kinematic chain, kinematic joint and mechanism. And in the last session we have discussed about degree of freedom also. Right, I hope everyone is enjoying this particular sessions on foundation course of theory of machine subject. So please share this session to your friends as well, right? So before entering into the lecture here itself, first of all, please everyone, there is a small request from our side. Please join this particular Telegram group, because here you will be getting every information regarding the all upcoming YouTube events that we are going to conduct in IMS Gate Academy YouTube channel. Apart from that, you will be getting all latest job notifications, and quizzes will be conducted in the Telegram group, so that it will help you in your GATE preparation as well, right? Next, very important information regarding, we have already started our live online program, okay, which has more than 800 hours of live classes. Apart from that, you will be getting one question booklet regarding the GATE previous year question, for technical, another book for the non-technical part, that mathematics and aptitude part, where all the branches, aptitude and mathematics questions you will be getting. So two separate books you will be getting. Apart from that, every subject theory and exercise books you will be getting. And very important feature of this IMS Gate Academy live program is 12 mentorship sessions. This sessions has been designed for every student, so that he or she can discuss his personal doubts, whatever the concerns he or she is having during his GATE preparation journey, whatever challenges the student or the aspirant is facing, he will always in direct contact with the faculty, and the faculty will take care of his GATE preparation journey, right? From the starting of the GATE journey until the GATE examination, faculty will be always in direct contact with the students. So whenever they will face any difficulty, as a faculty, we are always ready to help them, right? Apart from that, there is online test series available, chapter test, subject test, multi-subject level test, and also you will be having one thing, which is All India mock test series. So those important things are very, very important, okay? These, like, if I talk about this features in IMS Gate Academy live program, you will not get anywhere. That's what I can guarantee you in this thing. And if you join this IMS Gate Academy live program, definitely your GATE preparation will be always on a top-notch level, right? So in the last session, as I already told you, degree of freedom we have discussed. With that topic only, we will be starting our lecture, and then we will discuss GrasHoff's law as well, right? Now, so this is the question that was asked in the GATE examination, right? GATE 2004, for 2 marks they have asked this question. So I want everyone, please mention your answers in the chat box, okay? We have discussed completely regarding the degree of freedom, but remember, they are not asking degree of constraint, okay? Please take care of this thing. It is not degree of freedom, it is the degree of constraint. And I have told you the formula also. Degree of freedom formula is what? 6 minus the constraint, because the maximum possible degree of freedom will be what? 6. But in reality, actual degree of freedom will be what? 6 minus degree of constraint, right? So that is what we need to match with type of joint with type of constraint. Now, very important point, if I ask you, first of all, forget about the degree of constraint, tell me what is the degree of freedom here. What is the degree of freedom? If I talk about revolute, I hope you remember revolute, we have talked about, it is nothing but hinge joint, pin joint, okay? That is what known as revolute. It is having degree of freedom. What is the degree of freedom? 1. Correct? Degree of freedom will be 1. Cylindrical, degree of freedom will be 2, because both rotation and translation will be allowed. Spherical, degree of freedom will be 3, because the rotation in all 3 axes will be provided. So please, a very important detail that we should remember here regarding the joint also. Revolute, only turning is possible or rotation is possible. So degree of freedom 1. And if I talk about the cylindrical one, only rotation and sliding is possible. Only rotation and sliding is possible. And in the case of spherical, in all 3 axes, rotation is allowed. No sliding, no translation motion is allowed. So this is what the degree of freedom. Once this is understood, then you can easily talk about the degree of constraint. Because if degree of freedom is 1, it means 5 is what the constraint. 5 will be the degree of constraint here in the case of revolute joint, right? So degree of freedom, if it is clear, now we can easily match the answer here. Okay, very important thing. Degree of freedom for revolute 1 is 1, so degree of constraint will be 5, right? Cylindrical degree of freedom is 2, so degree of constraint will be what? 4. Okay, option number 3. Spherical degree of freedom 3, degree of freedom is 3 here, so degree of constraint will also be 3 here. So remember always this point, maximum possible degree of freedom is 6. But in real case, because of the connections, because of the joint, you will have degree of freedom somewhat less than 6. Because whenever the connection or the joint is formed, there is what the constraint is coming into the picture. Because of the joint or connection only, there is a constraint. And because of that constraint only, degree of freedom has decreased, right? If constraint is not there, if I talk about any single body which is having no connection with any body, it will have how much degree of freedom? 6. 3 translation in 3 axis, 3 rotation in 3 axis. Simple, right? So that's how you can match the answer here. So P will have option 2 here. Okay, option 2, cylindrical degree of freedom 2, answer is 3. So 2, 3, 1. So option number C will be the correct answer. 2, 3, 1. Okay, so 2, 3, 1. This is the correct answer. Option C will be correct here. Option C will be the correct answer here. Okay, so always remember maximum possible degree of freedom 6. But in real case, it will be less than 6 because of the constraint. I hope this point is clear to everyone, right? So if you have any doubt from the last lecture regarding degree of freedom, we have solved one problem also. Okay, I think two problems we have solved. So in the last session, so any doubt you are having from the last lecture of degree of freedom, you can ask here itself also in the live chat box. Okay, you can mention whatever the doubt or confusions if you are having, please mention in the chat box, right? Okay, coming to the next topic, guys, very important one, inversion. Very important topic, inversion. Mechanism already we have discussed, and again if I talk about mechanism, what is the definition we have discussed regarding mechanism? In the kinematic chain, if I fix any one link, it will convert into mechanism, right? Now we have not talked about which particular link has to be fixed. If there is a chain having 4 links, any one link out of 4 can be fixed, na? So based on which link is fixed, we can have a different mechanisms. So the process of obtaining different mechanism by fixing different link in the kinematic chain is known as inversion. But very important point that you need to understand, that whenever you are fixing different link, you should have a different set of motion. Okay, you should have a different output motion. If the output motion is same as it is, then it will not be considered as different mechanism. You should get different output motion. Otherwise, we can't say that mechanism is different. To get distinct mechanism, okay, please remember this point. To get distinct mechanism, we need to see the distinct output pattern of motion. Right, so inversion everyone should remember. So please note it down in your notebook as well. Everyone, this definitions you should note it down in your notebook as well, right? Now again, second point also you should remember here, in the process of this inversion, the relative motion of the links of the mechanism produced remain unchanged. It means like if 2 links get connected by a turning joint, so it will remain turning joint. Na? Link 1 will be rotating with respect to 2 or 2 rotating with respect to 1. It will not change. So relative motion between the links is not going to change if you fix any other link. Okay, so that basic understanding you should be having, right? So relative motion, the relative motion of the links that is there between the different links, it is not going to change based on the different link you have fixed to get different mechanism. No, the motion between the relative motion between the links, it is not going to change, but overall the output motion has to what change, then only it will be considered as a different mechanism or the new distinct mechanism that we are getting here. Okay, so that output motion has to change. Otherwise, we can't say na this mechanism is different. With respect to what we are saying, ki we got different mechanism. We got different mechanism because we are getting different output motion. Are you getting the point? So this thing you should remember. Okay, now coming to the mechanism part, which mechanisms we have to discuss in the syllabus of theory of machine. As far as our syllabus is concerned in the gate examination, total 3 mechanism we have to discuss. 4-bar mechanism, single slider crank mechanism and a double slider crank mechanism. Total 3 mechanism is there. So in this lecture, the topic is GrasHoff's law, which is related with the 4-bar mechanism. Okay, so we'll discuss the GrasHoff's law here. But before that, what is 4-bar mechanism? It's simply a mechanism formed by 4 links, and all the links will have a same turning joint. 4 links and 4 turning joints will be there. Clear? In single slider crank mechanism, there will be 3 turning joint and 1 sliding joint. In case of double slider crank mechanism, 2 turning joint and 2 sliding joint, or we can say pair also, right? So let us mention the detail also here. In 4-bar mechanism, 4 turning pair. Clear? 4 turning pair will be there. In case of single slider crank mechanism, 3 turning pair and 1 sliding pair. Clear? Double slider crank mechanism, in this case 2 turning pair sliding pair. Clear? So this basic details we should be knowing. So 4 turning pair in the case of 4-bar mechanism. In case of single slider, 3 turning, 1 sliding. 2 turning and 2 sliding will be there in the double slider crank mechanism. Okay, so please everyone note it down, this detail. Done? So please note it down, all the details that we are discussing here. You should parallelly create the notes here. Okay, in this foundation course, all the basic fundamental things we are going to discuss. So you should parallelly create your notes as well based on the lectures that we are discussing here. Done? Now coming to the GrasHoff's law, guys. As I already told you, 4 members will be there and the 4 turning pairs. So this is our 4-bar mechanism, right? Now in this 4-bar mechanism, as far as the GrasHoff's law is concerned, you need to understand a very important point. Okay, so there are 4 links. Out of 4, there will be one smallest link and there will be one longest link, right? 4 link will be there, 4 different length will be there. Out of 4, there will be one smallest and one will be the longest. So that is the one thing. And other 2 will be there. Okay, so let us mention the name here. Let us consider this as a smallest link and let us consider this as a longest link. Other 2 link length I am mentioning with P and Q. Okay, so please understand here, smallest by S notation, longest with L. Other 2 are P and Q. So I have mentioned the link length or the link dimension I have mentioned here. Okay, fine. Now as far as this law is concerned, so first of all, please remember it again, I am repeating, it is applicable for 4-bar mechanism. Okay, and 4-bar mechanism means what? 4 links having 4 turning pair. This definition is very, very important. Many times I have seen people will forget, they will just remember 4-bar means what? 4-bar mechanism means 4 links only. They forget about the connection. Connection has to be what? Turning pair, turning pair, turning pair and turning pair. There should not be any other pair apart from the turning pair. If out of 4 there are 3 turning and 1 sliding, then it is not called as 4-bar mechanism. And if it is not a 4-bar mechanism, then how you can apply the GrasHoff's law? Are you getting the point? You cannot apply the GrasHoff's law until unless you have confirmed that it is a 4-bar mechanism. So definition of 4-bar mechanism should be clear. 4 links and also very important point, 4 turning pairs. Correct? Fine. Now coming to the law. So the law is saying that the sum of shortest and the longest link length should not be greater than the sum of remaining 2 link length if continuous relative motion is to be maintained between the links. Simply it is saying smallest plus longest. This is the smallest, this is the longest. Okay, if I add these two, if I add smallest and longest, it should not be greater than the other 2 remaining link length summation. So smallest plus longest should be less than equals to P plus Q. That is what the meaning of GrasHoff's law. So any 4-bar mechanism following this particular rule, it will be called as, it is a GrasHoff linkage, or we can say GrasHoff's mechanism. Better word will be the GrasHoff mechanism, it will be. So any 4-bar mechanism will be called as GrasHoff's mechanism when it is following this rule. Smallest plus longest less than equal to P plus Q. P plus Q is the link length of other 2 links. Link length of other 2 links, other 2 remaining links. Because smallest I have figured out, longest I have figured out, other 2 will be there, whatever the dimension it is having. Right? This basic principle of GrasHoff's law, it is clear. And you will find there are lot of questions has been asked, not only in GATE examination, in other examinations as well. So GrasHoff's law is one of the most important topic in first chapter of simple mechanism. Okay, in the first chapter simple mechanism, this is the most important topic from which the question has been asked. In the GATE examination, multiple questions they have asked from this GrasHoff's law. So each and every important information should be clear. Okay, every information should be clear regarding the GrasHoff's law. So sometimes we will read it, we will understand it, but we will miss small points. Okay, so please make sure that whenever you are going to learn any concept, you should please very careful that whenever I am going to learn any concept, that concept should be complete. It should not be like half of the thing I have learned and remaining half thing I forget or I have not learned. In that case, you will be definitely doing mistakes. So whenever you are starting or preparing GATE examination, whenever you are starting your syllabus of any of the subject part, please make sure that the topic has to be complete. Okay, you should not learn the topic in just mid only. Okay, some of the parts you have learned, some of the parts you have not touched, so you have not learned those parts. So you will not be able to solve question in such scenarios. Right? So I have told you what kind of mistakes generally happens in the case of GrasHoff's law. 4-bar mechanism, first of all they forget that this law is regarding with 4-bar mechanism. This law is with regards to 4-bar mechanism, they will forget this thing. Next, what is the next thing? They forget the meaning of 4-bar mechanism. Meaning of 4-bar mechanism is what? 4 links. No. Apart from 4 links, 4 turning pair should be there. Out of 4 turning pair, if any of the pair is not turning or it is sliding or somewhat another kind of pair it is there, then it is not 4-bar. So GrasHoff's law is not valid. So these details at least you should remember. Now, this law is satisfied. Now coming to the case 1. Very important. Case number 1 of GrasHoff's law. Right? Case number 1 will be smallest plus longest less than P plus Q. Rule was less than equals to, na? So I can take less than. In that case also law is satisfied. Okay, in this case also law is satisfied. Right? Okay. So law is satisfied, fine. So GrasHoff's law is satisfied here. Okay. Now, there are 3 cases that we need to remember, and that cases are nothing but the conclusions that has been given by the GrasHoff's by doing number of experiments in the 4-bar mechanism. So that direct conclusion points we need to remember so that we can answer questions in the GATE examination. So first point is smallest link is fixed. Smallest link is fixed. First option. So if smallest link is fixed, so what is going to happen? You will get double crank mechanism, and I will show you all the mechanism here. You will understand what actually double crank mechanism is. You will able to understand how the links are moving in the case of double crank mechanism. Okay, so all those important animations we are going to observe here in the lecture itself. Okay, but before that, please try to remember this conclusion directly so that we can answer the questions that are coming in the GATE examination. Okay, see, first option is first case basically, smallest link is fixed. Which mechanism I will be getting? Crank, double crank. Second, link adjacent to smallest is fixed. Link adjacent to smallest link is fixed. We will be getting what? Crank rocker mechanism. We will be getting crank rocker mechanism. So there are four members, right? There are 4 members. Out of 4, there will be one smallest. So you have to figure out what is the smallest. Based on that, we will see which link is fixed. Either smallest is fixed, either adjacent to smallest is fixed, or opposite to smallest is fixed. Total 3 possibilities are there. Total 3 possibilities are there. First, smallest is fixed, then double crank. Second case, link adjacent to smallest is fixed. And the third case is link adjacent to smallest is fixed. Okay, link adjacent to smallest is fixed, and third one is link opposite to smallest is fixed. Adjacent to smallest already we have discussed the second one. So total 3 possibilities, either the smallest or the adjacent or opposite to smallest. So link opposite to smallest is fixed. So what kind of mechanism we are getting? Double rocker mechanism. Double rocker mechanism. Yes, correct mechanical word, correct, absolutely. Okay, so this important information we need to remember, guys, very, very important. Okay. So now next we will see the animation part here. So smallest link fixed, double crank, adjacent to smallest, crank rocker, opposite to smallest, double rocker. But these 3 cases will be valid. These 3 cases will be valid when this law is satisfied and this condition is there, less than P plus Q. Less than P plus Q, right? For example, I can mention here 2 and 7, okay? 2, 7, smallest link length is 2, longest link length is 7, let's suppose. Other 2 I can mention 3, 4, like this, okay? Let's suppose we can mention it 3, 6 we should mention, because summation should be correct, na? 3 and 6. 3 and 6. So if you add 3 plus 6, it will be 9. Okay. 2 plus 7, it is 9. Now it is equal. Okay. So equal case will be different. So let us write it here 4. Okay. In that case, I will write here 4. It becomes 10. So like this. So now the GrasHoff's law is satisfied. Like this, we have to check. In the question what they will give, complete mechanism with complete dimensions they are giving. From that I will check whether the law is satisfied. If it is satisfied, which kind of case it is. Either less than it is there or equal is there. This is the case number 1, this is case number 2. Case number 1 means smallest plus longest less than P plus Q. Second case will be smallest plus longest equals to P plus Q. So 2 different cases will be there. Right now, we are discussing case number 1, where smallest plus longest is less than P plus Q. Are you getting this point? Right? Law satisfied, fine. But how it is going to satisfied? Whether it is the case 1 or case 2. This thing we have to understand. Case 1. So this result we will remember. Okay. This result we will remember. Fine. Now, case 1 results we have understood. Now, let us see the animation part here. Please understand, everyone. This is what kind of mechanism? Double crank mechanism. Clear? Is it clear, everyone? Double crank mechanism. So you can easily observe both the links are going to have a complete rotation. Both the links is having complete rotation. So double crank mechanism. Okay, in your mind it should be clear that both the links will have complete 360 rotation. So first of all, crank, maybe some of the students will find this thing confusing. What is crank? Okay, crank is that link which rotates complete 360 degree. Which rotates complete 360 degree. And what is rocker? Rocker is that link which is not rotating complete 360 degree. Less than 360 degree it is going to rotate. Like it is oscillating, which means it is going to oscillate. Okay. So crank is that link which rotates complete 360 degree. Now let us move on to the next one. Crank rocker mechanism. Now you can easily understand in this case. See this movement. This link is what? Rotating like this, oscillating. This kind of motion will be called as rocker. Okay, but this link is having complete rotation. So this circle will be formed. This circle will be formed, right? In this case, both are rotating. So this is the circle of smallest small link. Another circle will be formed by the another link. So this basic understanding, okay, it will be clear. All this basic understanding of mechanism will get clear once you will see the mechanisms. Once you see the mechanism in front of you, then everything in this simple mechanism chapter will become very, very easy for you. You will never feel that it is confusing or difficult kind of thing. Because in front of you, you have seen the mechanism. How the link is moving with respect to each other. Everything is clear. Right? So crank rocker is also clear. So rocker is that particular link which is oscillating or which is rotating but less than 360 degree. Rotation is there. It is going to rotate like this, but that angle covered is less than 360 degree. Angle is less than 360 degree. Fine. Double rocker mechanism. Both the links will have what? Rotation but less than 360 degree. So they will be oscillating. So double rocker mechanism, right? So one basic understanding you should be having in a 4-bar mechanism, right? So please everyone see here. So let's suppose there is one 4-bar mechanism I have drawn here. So please understand here. So there is a fixed link. This one is fixed. This link is fixed in the mechanism. And let us suppose I have provided some input motion. Input motion I have provided. That input motion will be transmitted to this link, and actually the motion here, whatever we are getting, is our output motion. This one will be called as the link which is what? Transmitting the input motion to this link, output link. So this is input link and this is output link. Why it is called input output? Because here we are giving the input motion, na? So that link becomes input link, and here we are getting output link. So this link generally simply called as coupler, which is used for transmitting the motion simply. So whenever there is a 4-bar mechanism, you should have in your mind this clarity that there will be a link where I will provide input motion and there will be a link where I will be getting output motion. And both input-output motion, input-output link will get connected with this coupler, which is just a transmitting body, motion transmitting body. Is it clear everyone? Okay, and there is one link which is fixed here, right? So in 4-bar mechanism, input link where input motion is provided, output link where output motion we are getting. Simple funda. Done everyone? Okay. So what you need to remember, if this case is there, first of all you have to confirm that this is the case. If this case you have understood, then this 3 result we have to by heart remember. Okay, we have to remember this 3 result directly. Smallest fixed, double crank. Link adjacent to smallest fixed, crank rocker. Link opposite to smallest fixed, double rocker. Like that we need to remember here the cases. Done? Okay. All the 3 mechanisms we have seen. Now coming to the second case, case number 2. Okay, let us move on to the case number 2 guys here. Everyone see. When smallest, longest, okay, if I add, it will be equals to sum of other 2 remaining link length, that is P plus Q. So smallest plus L, okay, smallest link length plus longest link length, if I add, it will be equals to P plus Q, fine. Now, law is satisfied in this case also, that's why this is the case number 2. But one thing I am assuming here, all link length is different. This is what I am assuming. For example, 2 and 5, 3 and 4. So I can assume 2 as the smallest link, 5 as the longest link, and 3 and 4 as the other 2 link. Fine? Is that correct? I hope there is no issue in this case. 2 is the smallest link. Let me mention here also. Smallest, longest, P, and this is Q. Smallest link length, longest link length, P and Q, like this. Is it clear? Fine. So here 2 different possibilities are there. Like I have mentioned, all link length is different. There will be another case possible here. What is the another case? Where we will have equal pairs, like 2, 5, 2, 5. Equal pairs we are having. 3 plus 4, 3 plus 4. Equal pair of link length we are having, let's suppose. So this is also another possibility. So please remember, if in case number 2, all link length is different. Okay, this case I will discuss separately. In the upcoming slide, I will discuss it separately, right? So don't worry about it. If all link length is different, in that case, what is going to happen? Okay, in that case, the previous result we need to follow. Previous result basically means this 3 result. This 3 result will follow again. Okay. So S plus L equals to P plus Q, fine. It is law is satisfied. GrasHoff's law. Okay, GrasHoff's law satisfied. And one more thing we have figured out ki all link length is different. Once it is clear, then directly you should remember that this 3 result will follow. That we have discussed in the previous case number 1. Smallest fixed, link adjacent to smallest, link opposite to smallest fixed, and then this type of mechanism is there. So this result will again repeat. This result will again repeat in this case also, but there is a condition. What is the condition here? Condition is all link length is different. All link length is different. That is the condition here. Please everyone, this is very important point. So if this condition is also there, then previous result we need to follow. Previous result we need to follow here. Fine. Is that clear? Okay, done. Now, as I told you, this is the condition 1. There is another condition also there when we have equal pair of link length. When we have equal pair of link length. Okay. So equal pair of link length if we are having, in that case what will happen? One possibility is there. Link having same length are placed opposite to each other. Yet simply I have told you na, either we have this condition 1 where all link length are different, or we can have equal link length, okay, or equal pair of links, right? equal pair of length we are having. So 2 plus 5, 2 plus 5, 3 plus 4, 3 plus 4, smallest plus longest equals to P plus Q. So this set of this type of cases will be considered as different, right? It is not similar to that one. So this is one case. Another case was that we have just now discussed, na? 2 plus 5, 3 plus 4. Here also smallest plus longest is P plus Q, fine, no issue. But all link length are different. Here equal pair, 2 plus 2, 5, 3, 4, 2, 5, 2, 5, 3, 4, 3, 4. So this is a separate case, this is a separate case. That different link length case we have already discussed. Now we are discussing equal pair of length. Done? Is it clear? Okay. Now, so as I told you, if I place equal links opposite to each other, if I place equal link opposite to each other, that is the one possibility. Second possibility will be what? When we place equal link adjacent to each other. Total two possibilities will be there. Either I can place equal link length opposite to each other, or second case adjacent to each other. So if I place opposite to each other, what will happen? This kind of parallelogram will be formed. Okay, so for example, this is smallest, placed opposite to each other, longest, placed opposite to each other. Fine. So this is known as parallelogram linkage. Parallelogram linkage it is called. Okay, and in that case, if I fix any of the link, I will be getting double crank mechanism. But I will be getting double crank mechanism I will be getting. Okay. So equal pair of length. In that case, one more sub case is there. Link having same length are placed opposite to each other. So parallelogram will formed. Fine. Another case where the same link length are adjacent to each other, right? Same length are placed adjacent to each other, right? So this kind of formation you will see smallest, longest and longest, right? And this type of formation known as deltoid linkage. That kind of formation is known as deltoid linkage. Is it clear, everyone? Fine, done? Okay. In this particular case, what is the result we need to remember? If smallest link is fixed, you will get double crank, and if longest is fixed, you will be getting what? Crank rocker mechanism. So this result we need to follow. But in case of parallelogram, you can fix any smallest or longest. You will always get double crank mechanism in case of parallelogram. But in case of deltoid, smallest fixed, so then double crank. But if longest is fixed, crank rocker. So in GrasHoff's law, there are so many results that we need to follow. Apart from the results, correct conditions also we need to remember. So this result will be applicable for this condition, right? Right. So this result will be applicable for this particular condition. I hope you are getting the point. This result is applicable for when this case is there and this condition is there. So there are so many things we need to remember in this GrasHoff's law, and that's why many times the mistakes will happen. Definitely, if we don't remember it properly. Okay, so that's why please try to remember the result correctly. There is no use if we are remembering but we don't know the conditions under which that result will be applicable. So that should not happen, right? Okay. We'll see some previous year question, guys. So deltoid linkage we have discussed. Coming to the some questions here. So first of all, this question, guys. FOBA mechanism shown in the figure. All the dimension it is there, OA, AB, BC and this OC. Okay, and all the link length it is given. Okay, all the link length is given here. First of all, I will mention the link length here. OA 3 centimeter, then AB 5 centimeter, then BC 6 centimeter, and then OC 7 centimeter. Now first of all, you need to tell me which link is fixed here. Which link is fixed? Tell me immediately. Everyone should mention in the chat box. Mechanical world, what will be the link which is fixed in this particular case? Which link is fixed in this case? Tell me. Link OC is fixed here. Okay. Which link is fixed? OC. Okay. Link OC is fixed. Fine. Yes, Aman. Yes, correct. Absolutely. Bottom one. That OC is fixed. Now OC is fixed. Now can you tell me which kind of mechanism it will be? Aman, tell me what will be your answer. Which type of mechanism it will be there? Fixed link we have figured out. OC is the fixed link. So can we also talk about whether this kind of mechanism is double crank, double rocker, crank rocker, or double crank rocker mechanism? What kind of mechanism it will be? I've told you, first of all, check the GrasHoff's law. Can I say 3 is the smallest link? Yes, 3 is the smallest link. For sure, 3 is smallest. 3 is smallest. Longest will be 7. Other two are 5 and 6. 3 plus 7, 10. 5 and 6, 11. So, GrasHoff's law is valid. Now, this kind of GrasHoff's law is valid. That is our case number 1. It is case number 1. Option B, Aman is saying. Okay. So, case number 1 is correct. Now, after this, we need to check which link is fixed. Which link is fixed with respect to smallest one. So, if I check here, link adjacent to smallest is fixed. As 3 is our smallest link, is adjacent to smallest is fixed. Whenever adjacent to smallest is fixed, we will have a crank rocker mechanism. How double rocker mechanism? How double crank? No. First of all, GrasHoff's law is valid, and then we have to do what? We have to check which link is fixed with respect to smallest. Adjacent to smallest is fixed. This is my smallest link. Adjacent to smallest link, this one is what fixed. So whenever adjacent to smallest is fixed, we will have crank rocker mechanism. See, we have written here. Link adjacent to smallest fixed, crank rocker mechanism under this case. Aman, is it clear? Under case 1, when smallest longest is less than P plus Q and link adjacent to smallest is fixed, remember, link adjacent to smallest is fixed, crank rocker mechanism is there. Okay, so that's why first of all figure out which kind of case it is there, then see the results. And always check with respect to smallest. So 3 possibility, either smallest, adjacent to smallest, or opposite to smallest. Okay, got it, clear. So yes, this one. So answer here will be crank rocker mechanism, adjacent to smallest. Now coming to this question, it was asked in GATE 2018. A 4-bar mechanism is made up of links of length 100, 200, 300 and 350. Okay, 100, 200, 300, 350. Like that I have mentioned here. If the 350 link is fixed, okay, so this 350 is only fixed. 300, 200 and this is 100. Now tell me what will be the answer? The number of links that can rotate fully. The link which can rotate fully is what? Crank only. Crank is that link which can rotate fully, which means complete 360-degree rotation it can perform. So first of all, GrasHoff's law you need to check here. Okay, smallest 100 plus 350, that is the longest. Other two link length are 200 and 300. So it will be 450 and here it will be 500. Fine, correct. GrasHoff's law is valid. So this is what we have checked, and it belongs to case number 1. Case number 1 it is there. So we have to check which link is fixed. Always check with respect to smallest. Smallest is what? 100. Adjacent to smallest is fixed. It means crank rocker mechanism. Whenever we have a crank rocker mechanism, it means there will be one link which will have a complete 360 rotation. That's why we are calling it as a crank, na? So one link will have a definitely 360-degree rotation, or which will rotate fully. So the number of links that can rotate fully is 1. Answer will be 1 here. Absolutely correct, Aman. Correct. Your answer is correct. Now this question, GATE 2020, the question was asked, this one. Tell me, what will be your answer? For the mechanism, okay, in the question itself they have mentioned, for the mechanism to be crank rocker mechanism. When it is mentioned here itself, it is a crank rocker mechanism. It means link adjacent to smallest is fixed. Link adjacent to smallest is fixed. And in this case, the fixed link is PS. So fixed link is clear. Now either this 300 can be smallest or this one can be smallest. It depends. But we have to make sure that GrasHoff's law should be valid here. Tell me, what will be your answer? Okay, we can go by the options also. Let's suppose if you say, sir, 200, let's check with 200. Okay, if it is 200, it means 200 becomes my smallest out of all 4. And adjacent to smallest is fixed, crank rocker, fine, correct. So 200 plus longest is what? 600. Other two link length will be 300 plus 400. So here answer will be 800 and here 700. So in this case, law is not satisfied. So this is wrong. Option A is not possible, because it is not following the GrasHoff's law. Yes or no? Aman, is it clear? Okay. Now let us check option number 2. Option number 2, that is 300. If it is 300, so out of this 300 or 300, 300 is same. So anyone can be considered as smallest. Out of 300, anyone can be considered as smallest. Na? So longest is again 600 only. Other two will be 300 plus 400. So this is 700 and this is 900. Obviously again law is not satisfied. This option is also wrong. Right? Coming to the next option, 350. Again, directly you can say, na, sir, 350, it is there. Smallest will be this one, 300. 300 and 400, again, it will not be followed. GrasHoff's law will not be followed. Yes, Aman, answer 80 is the correct answer. 80 is the correct answer, because 80 plus the longest one is 600 and other two will be 300 and 400. Now here it will be 680 and here it will be 700. So obviously law is satisfied. Done. Law is satisfied. So option D, 80 mm is the correct answer here. Like that we have to solve the questions. Done? Great. Super. So in today's lecture we have discussed about the GrasHoff's law related to 4-bar mechanism, right? We have seen all the cases and we have seen some of the GATE previous year questions also. Remember, whenever GrasHoff's law is not valid, no matter whatever link is fixed, you will always get double rocker mechanism. Remember, this point again, or you can mention in your notebook also. If in a 4-bar mechanism it is not following the GrasHoff's law, it means that no matter any link you will fix, you will always get a double rocker mechanism. For all configurations, you will get double rocker mechanism, right? Okay, so this was the last question that we have discussed. Okay, this also previous year question done, and this is the some practical some example. Okay, so that simple example that we have discussed, these previous year from GATE 2018 and from GATE 2020. So these are the previous year questions. I hope it is clear to everyone. All the doubts regarding the GrasHoff's law, it is now clear, right? Done. Now in the upcoming session, we will be discussing single slider crank mechanism, where we will talk about crank slotted quick return motion mechanism and Whitworth quick return motion mechanism, right? In the next lecture, we will discuss about single slider crank mechanism, and we will discuss crank slotted with the animation part. With that animation, you will understand how the links are moving with respect to each other. Okay, everything will be clear. Okay, and also the Whitworth quick return motion mechanism. With animation, everything will be clear to you. Okay, thank you so much, guys. In the next session, we are going to discuss the slider crank mechanism. Okay, stay tuned with the IMS GATE Academy YouTube channel for more upcoming lectures from the foundation course. Thank you so much.